primary key up here, and they always point to a row in another table. And so we have modeled all those relationships, and you will notice that in this entire database, the who made who only appears once. The word rock only appears once. The word AC/DC only appears once. What we have is we have duplication in our data, but we are duplicating the relationships, i.e. these little integer numbers, not duplicating the data itself. And in something that's this small, it seems irrelevant. But if you have billions of records or hundreds of millions of records, it's very relevant. Very, very relevant. So the next thing we're going to do is take a look at how you actually reconnect all this stuff together once we've sort of blown it out in these, using these foreign keys and hand constructing all these relationships, now how we bring it back together to show the data to the user. So now that we've carefully constructed our relationships in the tables, we need to reconstruct the data to show our users. And you can kind of see how you would go pull this stuff together, but there's a wonderful capability in relational databases called join that brings this all back together. And so we have done this for efficiency of storage, efficiency of scanning, etc. But we do need to traverse these foreign keys at times, and the database software will do this for us automatically. So the join operation basically is a way to specify in a select statement that you want to pull data out of more than one table, and then specifying using what's called the on clause exactly how you want that data pulled out. And so here we go. We already have a table, an album table to the artist table, and the foreign key, and we want to, in effect, pull data from both the album and the artist, the album title and the artist name, and we want to show that. And so we're going to say select, which is the same select statement. Here's a little different syntax. This is the list of fields. This is table.field. So it's the album title and the artist dot name, comma there, from the album. And I always start with where the little arrow starts from, album joined with. So that is going to walk down this connection from album to artist. Album joined with artist, don't say with, I just say it, on, and then this is the conditions upon which that join is going to happen. When the album's artist ID, which is this column here, album's artist ID matches, think of that as is equal to or matches the artist's ID. And so it only connects the rows here when there is a match between these two tables. And so if we look at this and we see that you know, this one matches this one and this one matches that one, and so it's the join connects conditionally, and it connects when the on clause is satisfied. And so when this whole join runs, this is what we get. So you select all this stuff. Now this is an abstraction. Are you writing a loop? Are you doing two nested loops? How are you exactly bringing all this data together? We don't care about that, because that's the beauty of SQL. That's the beauty of how we do this in a database. So now if we can just run this command. So let's grab this command. Select track title, genre name from track, join genre, that exact query. Case of keywords doesn't matter. And we go over here and we run this as SQL. And we run it. We get, oops, I got too far. Let's do this one. So let's do that one there. Select artist name. I have to add that one to my little cheat sheet. The next time you see the cheat sheet, it'll be right. So the title, so this is coming from one table and that's coming from another table. Okay? And so that's one. So here is something we can do that gives us a little more detail on that. We can say, so this is where the connection, and so you can think of the join as sort of spreading one table and connecting it to the other table. And so what we're going to show here is it's exactly the same. The only thing we're going to do is we're going to add these two columns so you can see where the match happens. And so this is one table, this is another table, and these are the kind of columns in common, even though they're not. They're the columns that match. This is where the on clause is happening, right? We have taken this table joined with this table on these two things connecting with each other. So you can almost, in some language, some variants of SQL, this would even be a where clause. So you connect these two rows, but only connect them when those two numbers match. So you can see, I mean, if we run this, I'll just run this. And again, you just see this is where it connects. Okay? Now, interestingly, we can see what happens and what the purpose of the on clause is if we omit it. So this is exactly the same as that previous query, except there's no on clause. So it's select all four of those fields from the track joined with the genre. So it's basically taken the track table and the genre with a join, but no on clause. So it's not filtering for matches. This is a match, this is a match, that's a match, that's a match. But we don't have an on clause, so the matchness doesn't matter. And so you're going to get all possible combinations. And literally, if there were, 10 on one side and 30 on the other side, you would get 300 rows in that join. So it'd be all combinations, except the on clause reduces the combinations. And you might think, whoa, this is really inefficient. And I will say that's what my first reaction was when I first saw this, but it's not inefficient. That's the beauty of abstraction. That's the beauty of SQL. You say do it, and it just figures that out. So let me grab this, and you will see that we can run this one as well. And that kind of gives you why the on clause is important, because now we have a whole bunch of these things. And the on clause just filters that out. So if we would just add the on clause back in, then that would only show the ones we showed on the previous slide. So that's why the on clause is important. The join is like all possible combinations of all pairs of rows between these two tables. On is, oh, but only where these two things match. Now you might think that it's inefficient, but the on clause turns out to be the way it becomes efficient. Okay. So now we're going to do the same thing where we're just going to take the track title and the genre and going to connect that together. So we select this. We need to join from one table, join to the genre table with an on clause. And so we're going to make those connections. And the only thing we're going to look at is the title and the genre name. Oh, oops. And then run that. And so we got the title and genre name. Now the thing you'll notice is for the first time, we now have replication of string data in a vertical dimension. That's okay, because the data is not replicated in the database. The data is now replicated as a result of the join. And so we are going to reconstruct what the user wants to see, which the user originally, all the way back to the beginning, wanted to see the duplicate information in the vertical axis. But now we're reconstructing it. We didn't waste the space or performance in our database, but we still have to show them. And so now the next thing we're going to do is a monster. We are going to reconstruct across all four tables. And you might think this is really hard, and sure, it's going to be a little tricky, but as long as you follow the naming convention and the naming convention makes sense, we're going to do a select from the track's title, the artist's name, the album's title, and the genre name. From the track, join genre, join the album, joined artist. And so the joins follow the little arrows, right? And then the on clause qualifies each of those arrows, when to follow the arrow. And then this becomes pretty easy. It's a foreign key. The track's genre ID, that's a foreign key, equals genre.id. That's primary key, that's a foreign key because I name it that way. And I know that this goes to that genre table because I name it that way. And track's album ID is equal to the album's ID, foreign key, primary key, and album's artist ID is equal to artist's ID. After a while, you can type these pretty fast as long as you follow a naming convention and you know the naming convention. So this looks like it's really hard to do, but after a while, it's really just a pattern. So let's go ahead and run that one. And it will, assuming we've done everything right, replicate all the data. So there's all kinds of vertical data now being replicated. Every column has vertical data. Again, it's not in the database. The select and the join are reconstructing vertical